Shoot. Oh well. So there'll be at least two more assignments. The one that I have for 7, 8, and 9 is like 5 pages right now. So I've got to go back and like cut some questions out because that's a little bit too much. Um, because some of the stuff is asking things more than once. So graphing, we're going to look at basically three things today. We're going to talk about base functions. We're going to talk, which is what we need to start. What are the transformations? Again, something that we've done before. So it's really, and then going through an actual graph. So base functions for logarithms. Well, this is log base 3, which is so this equation is the inverse, whoops, of y equals 3 to the x. We know when we did these, we did -1, 0, 1, a third, 1, and 3. So our table of values for this is the inverse of that. So a third, 1, 3, -1, 0, 1. So it's the same idea as we're going to take, it's just instead of putting our x values, we can actually use our logic to say, well, those are always going to be -1, 0, and 1. What are the x? So in this case, we have a third, a -1, 1 and 0, 3 and 1. So this is going to have a vertical asymptote at x equals 0. This one has no y-intercept, and it has an x-intercept of 1 and 0. So if we can get that base graph, well, we can transform it. We have a set of key points. We can identify transformations, do a mapping rule, and change some stuff. Even if the base is something weird. So if we go to the logic, if we've got -1, 0, and 1, log, what value of x do I need to make this L1 is a half. To get the log of 1 is 0, and then the pattern is 2. If we want to check, y equals a half to the x. We have -1, 0, 1. A half to the 0 is not 0, stooge. A half to the power of 1 is a half, and that's 2. So instead of having the decay, this one is going to be over 2, down 1, over 1 and 0, and a half and 1. So this one and if we did the next point, I'm pretty sure it would be somewhere over there, because if we had 2, oh, sorry, -2, a half to the -2 is 4. So, oh, 4 and -2. And my lines are awful. But that's the idea with our base function. So we need to be able to identify the base function. Log of base 4 of x. -1, 0, 1. 1, 4. And to know, oh, that's going to erase too much stuff. I just want to, there we go. Okay, apparently that's in the black ink now. So same idea as we've done before. That's a vertical stretch. That's our horizontal stretch. Horizontal translation. Vertical translation. So this graph has a vertical stretch of 3. There's no bracket here, so we assume that there's a bracket there, so this one would have a vertical translation of -6. There's no other transformations. We can do a mapping rule of xy goes to x and 3y minus 6. We can build our new table. The x's don't change. And I did it again. Why did I do that again? Why didn't somebody say, McKay, you're dumb? Quarter. 3 times -1 is -3. Minus 6 is -9. That doesn't change. 3 times 0, so that's -6. That doesn't change. 3 times 1 is 3. Minus 6 is -3. And we can plot those points and do all of our stuff. We'll talk about just a sec. Now I have to go check to see. That's not a, yeah, that's a vertical asymptote. Okay. Log base 5 of 3 onto x plus 2. So this one has a horizontal, oh, sorry, start log base 5 of x. So our initial table, 5, 1, and 1/5. This one has a horizontal stretch of 1/3. This has a horizontal translation of 2. So this one, the new table is going to be really messy. The y's don't change. And 1/3 of a fifth. Oh dear. 1/3 of a fifth is a 15th. So 1/15 plus 2 is 30, 31. Third of 1 is a third. A third plus 2 is 6. A third of 5 is 5/3. And that's going to be. Would I myself make you do a graph like that? Probably not. If I did, it would solely be by accident because I was going through and doing something too quick and I forgot. But this is stuff we've done before. Ooh, base. Log base 3 of x. X, y. So it's that a third. 1 and 3. -1, 0, 1. So we have a vertical stretch of 2, a horizontal translation of -4, a vertical translation of +5, a reflection because it's reflecting the negative, because we're changing all of our y coordinates. So our mapping rule would be x minus 4, comma, -2y plus 5. And I'm not going to build that table because it's just going to get to be, well, that's not as bad as I thought. A third minus 4 is 1 minus 12. 1 minus 4 is -3, -1. So 2 plus 5 is 7. That's a 5, and negative 2 plus 5 is 3. Because our normal log looks like that, we are reflecting in the x-axis, so it's going to drop. Everything looks a-okay. So when we did exponential function, well, I guess we'll look at kind of this one. We're looking for a vertical asymptote instead of a horizontal asymptote. Actually, I'm just going to go back and quickly. So if this was 3 to the x, the original graph, negative 1, 0, 1. So when we did all of this business, we moved our horizontal asymptote was related to the vertical translation. We move that up and down. Now we're moving our vertical asymptote is related to our horizontal translation. Because if I move this left or right, I move my vertical asymptote. That's what we're, base function. Oops. Y equals log 3 of x, a third, 1, 0, negative 1, 0, 1. So there's our base thing. Transformations, horizontal stretch is 1, there's nothing. Vertical stretch is 2. Horizontal translation is plus 4. Vertical translation is negative 1. We have no reflection. So our mapping rule, xy goes to x plus 4. And to y minus 1. So our vertical asymptote now is at x equals 4. When we graphed our exponential functions, we plotted everything based on that. So I can, when I go down to my graph, I can say I know I have a vertical asymptote somewhere over here. And 1. So that's our original. Once we transform it, well, let's do all of the stuff that's nice and simple. 1 plus 4 is 5. That should be 3. 3 plus 4 is 7. 2 times negative 1 is negative 2, minus 1 is negative 3. 2 times 0, so that's minus 1. 2 times 1 is 2, minus 1 is 1. That gets to be a little bit, and I've been doing these kind of in my head. Plus 4 is a third. 4 as a fraction over 3. 3 times 4 is 12. So that is 13 thirds, which is 4 and a third. So we have our table. I just want to extend that a little bit more. So let's plot the points that are easy. 5 and negative 1. 7 and 1. And 13 thirds, which is 4 and 1/3, and negative 3. And what? 2 times... Oh, that really bugs me. Why does that do that? Yeah, 2x, 2y minus 1. 4, 5, 6, 7. Arg. Hmm. I can't draw. I'm sorry. I wish I could. Kind of looked okay. So instead of having a distance of 1, we have a distance of 2. The one that I'm negative 1, 0. 2 times 1 is 2. 2 minus 1. 2 times 0 is 0 minus 1. 2 times negative 1 is negative 2. My math is right. X-intercept, that's a little bit tricky to find. Y-intercept, not applicable. Domain, X is greater than 4. Range, Y is contained in the reals. Because I'm so horrifically bad at graphing, I can't. X-intercept is when Y equals 0. That one had an X-intercept at 1. We could solve for it, but I'm not all that worried about that as long as we have those points. Have I done everything? Everything looks okay. So it's kind of, we're just extending everything that we've done before. If you have some time, you can do the same business for those two graphs. And that's all I have for today. Tomorrow we'll go over a couple more things. I put, I'm looking for this. Files. So the new stuff is in there. This for practice we'll go through, and that has some more examples, and we'll go through that tomorrow. But that's everything for today. Go outside, enjoy the enjoy the sunshine and the 20 some odd degree weather. Does anyone have any questions? Are we good? All right. Have a good afternoon. Enjoy the sun. Don't work too hard. We will talk to you all tomorrow. You're welcome.